Alrighty, in this video we are going to be talking about properties of integration and FTOC. First things first, continuity implies integrability. So if your function is continuous, then you can integrate it. Great. Pause the video, look over the properties of definite integrals because we'll need it for these couple examples with graphs. And then with these integrals right here. Okay, so for number 1, we want to find the integral from 0 to 2 of g of x, given that the g of x is our graph right here. And what we want to do is just take the area from 0 to 2, aka this lovely triangle right here. So that's just going to be 1/2, 2, 4. You don't need to simplify it, but I'm going to simplify it for prettiness, and that's just going to be 4. Now, the integral here from 2 to 0, one of the properties is this right here, where we're just going to negate it. You always want your lower limit to be at the bottom and your upper limit to be on top. So here we want negative 0 to 2 g of x dx, which means that our answer here is going to be negative 4. Okay, the integral from 2 to 6 of g of x, this is going to be my semicircle. This is going to be 1/2 pi r squared, 1/2 pi, my radius is 3, this is going to be 9 pi over 2. Now, notice how my area is below the curve, not the curve, below the x-axis. Since it's below the x-axis, I need to make sure that my answer is negative. Number 4 is the integral from 0 to 7. We already figured out what the integral from 0 to 2 is and 2 to 6. One of the properties that we're going to be using is this property right here, where we're just adding the integrals. So from 0 to 2, from 2 to 6, and then we're just going to figure out what 67 is. The integral from 67 is just a lovely triangle that we got to find. That's just going to be 1/2, 1 and 1. We already know that the integral from 0 to 2 is 4. We know that the integral from 2 to 6 is negative 9 pi over 2. And then we know that the integral from 6 to 7, that little small triangle, is just 1/2. So this right here is your lovely answer for number 4. All right. Looking at 5, 6, 7, and 8, where we are using properties again, I want to find the integral from negative 1 to 4 of h of x given h of x right here. So a couple of things that we know. We know that from negative 1 to 8, the whole integral, that is going to be 16. So what I like to do is sometimes make a little number line telling me what I know and what I don't know. So from negative 1 to 4, that's what we're trying to find. Now from 4 to 8, I know what that is because that is 5. And then the whole thing is 16. So this is going to tell me that the integral from negative 1 to 4 is 11. Likewise, for number 7 here, where we want to find the integral from 8 to 4, I'm going to rearrange this so it is negative. And then the integral from 4 to 8 of k of x dx. We know that here, that the integral from negative 1 to 8 is negative 2. So this whole thing right here is negative 2. And I know that the integral from 4 to negative 1 of 2k of x dx is 6. What I'm also going to do here is change it so that I have the integral from negative 1 to 4, 2k of x dx is equal to negative 6. I'm also going to divide by 2, one of my properties right. So right here, I could just take out the coefficient. So now this becomes the integral from -1 to 4. K of x dx is equal to -3. So from -1 to 4 is -3. And then to get my integral from 4 to 8, that is going to be 1. But then because I have a negative symbol right here, my final answer is just -1. Now, number 6 and number 8 are a little bit different because you have the +1 and the +2 up front on number 8. We are going to split this up. That's one of the properties. So I have the integral from 8 to 4 of -2 h of x dx plus the integral from 8 to 4 of 1 dx. Once again, I am going to change this integral right here and this one, honestly, so that my lower limit is 4. So I'm just going to negate that. And this right here. Okay, now we know from this right here that the integral from 4 to 8 is 5. I could move this up front. So I'm going to have 2 times 5 for this one right here. And then this one right here, one of the properties of a constant is this one right here, because this is essentially a rectangle right here with a length of b minus a with a height being c. So that being said, that is the same thing as saying 1 times 8 minus 4, or just 4. So 10 minus 4 is going to give us an answer of 6. And then finally, we have number 8 here, where I have the integral from -1 to 8 of 2 minus the integral from -1 to 8 of, let me move that 3 to the front, and we have this right here. Okay, so we know from this property right here that the integral from -1 to 8 is -2. So I have 2, 8 minus -1 minus 3 times -2. This right here becomes 9. This becomes +6. So then our answer is just 2 times 9 plus 6, or 24. All right, so that was properties of integrals without doing any integration. Honestly, we just found area, and then we used properties based off what they gave us. In the next video, we are going to be looking at the fundamental theorem of calculus and seeing how we can find the area under the curve based off of this right here.